given 9 parallel lines and their equations. So we have question 1. Given ABC has vertices at A 3, 7, B negative 1, 1, and C 5, negative 3. Point D lies on line AB. Point E lies on line segment AC. Line segment DE is a mid-segment of triangle ABC. Prove DE is parallel to BC without using the triangle mid-segment theorem. Alright, so we're reading the following proof for this problem and then follow the instructions. So triangle ABC has vertices at A 3, 7, B negative 1, 1, and C 5, negative 3. D lies on line segment AB. E lies on line segment AC. Line segment DE is the mid-segment of triangle ABC. The reason, that is the given information. Alright, point D is the midpoint of line segment AB and E is the midpoint of line segment AC. Reason, definition of blank 1. Okay, so let's go and look through our options for blank 1 and find out. Okay, so blank 1, we're going to drag and match each numbered blank to the answer that correctly satisfies the corresponding blank in the proof. Okay, so the midpoint of AB and E is the midpoint of AC. That is the definition of a mid-segment. So I'm going to be looking for the definition of a mid-segment. So definition of triangle mid-segment. That is our option. So now I'm going to come here. Point D has coordinates blank, midpoint formula. Okay, so let's look at the coordinates. We can find that out just by looking at it. So it is point D has the x coordinate of 1 and a y coordinate of 4. So I'm looking for coordinates of 1, 4 for blank 2. And I see them right there. So you click it and drag it. Point E has coordinates. Alright, let's look there. So it has an x coordinate of 4 and a y coordinate of 2. So blank 3 is 4, x coordinate of 4, y coordinate of 2. So click and drag it. Alright, blank 4. The slope of blank is negative 2/3. Okay, so it looks like we're going to be needing to find a slope of a line, and I'm going to scan through here, and I noticed that on statement 7 it has the segment DE. So I am going to look at segment DE and verify if the slope is in fact negative 2/3. So for segment DE, the slope is equal to, so from D to E, the rise or our vertical distance would be 1, 2, and I went down, so it's negative, and the horizontal distance is 1, 2, 3. So it is in fact negative 2/3, and so line segment DE is for our blank 4. So blank 4 is line segment DE. The slope of BC is blank 5. So let's look at DC. So DC's slope. Alright, so not DC, BE, BC. I apologize. Okay, so the vertical distance is 1, 2, 3, 4. And I went down, so it's negative 4. And my horizontal distance for my run is 1, 2, 3, 4, 5, 6. And if you hear little grunts and groans in the background, that's just my little one moving around in his sleep. So m is equal to negative 4 6 reduces down to negative 2/3 if they don't have either negative 4 6. So we're looking for negative 4 6 or negative 2/3 for blank 5. So blank 5 is negative 2/3. Alright, blank 6 is our reason. So line segment DC is parallel to line segment BC, blank 6. Okay, well they just used the slopes of DE and the slope of BC, and we found that they were the same. So I'm using it for parallel lines, slope criterion for parallel lines. That's what we were wanting to prove. Alright, so there are our blanks for question 1. Question 2. Line L contains points A, negative 2, 2, B, negative 1, 0, and line K contains points C, 0, 4, and point D, 1, 2. A, what is the slope of line L? B, what is the slope of line K? And are they parallel? Okay, so calculating the slope of L. I'm going to use the 2 points that are given, and I'm going to remember that slope is our rise, which is our vertical distance. So I'm going to use the y coordinates because that represents our vertical distance, and I'm going to take 2 minus 0. And then I'm going to take the run, or the horizontal distance, and I'm going, since I started with point A, I'm going to start with point A's x-coordinate again. So negative 2 minus negative 1, and this is minus a negative does turn into addition, so then we have 2 minus 0 is 2, negative 2 plus 1 is negative 1, and I'm going to get rid of this. 2 divided by negative 1 is equal to negative 2. Alright, so that's our answer for A. So I'm looking for an A negative 2. So A 1/2, no. A negative 1/2, no. A2, A of negative 2. Alright, so now we're going to find the slope of line K. We're going to do the same thing since we have our 2 points. We're going to use our coordinates. So again, our rise is our our vertical distance, and we're going to use our y coordinates. So I'm going to take 4 and subtract 2, and then we're going to take our run, which is our horizontal distance. So 0 and 1, and since I used point C first for our y coordinate, I'm going to use point C's x coordinate first again. So 0 minus 1, that's going to equal 4 minus 2 is 2, 0 minus 1 is negative 1, and 2 divided by negative 1 is negative 2. So again, I'm looking for B of negative 2, and it is right there. And then C, are the 2 lines parallel? Yes, because they have the same slope. Alright. And I'm going to jump down here to question 4. Quadrilateral ABCD has vertices A at negative 2, 3, B at 0, negative 3, C at 4, 1, and D at 2, 7. A, which statements about the quadrilateral ABCD are valid, and what conclusion can be drawn from the valid statements regarding quadrilateral ABCD? Okay, well, I'm just scanning through the options and it looks like it's asking a lot about slopes of line segments. So let's first find our slopes of our line segments. So we're going to have line segment AD, which is right here. We're going to have line segment BC, and the reason I'm jumping to BC is because if these two line segments are parallel, then I want to know, and if line segment AB is parallel to line segment DC, then we have two pairs of parallel lines, which makes it a parallelogram. So that's why I lined it up with opposite sides. Is because I have a plan in mind and I want to just be able to quickly compare the slopes. So AD, let's find the slope, and I'm going to use the tools that it's given me, which is counting it out. So from A to D, my vertical distance is going to be 1, 2, 3, 4, and it's positive since I went up, and the horizontal distance is going to be 1, 2, 3, 4, and it's going to be positive since I went right. So 4 divided by 4 reduces down to 1. So now I want to check my BC. So from B to C, my vertical distance is 1, 2, 3, 4. That's our rise, and it's positive since it went up. And we're going to check our run or our horizontal distance. 1, 2, 3, 4. 4 over 4 reduces down to 1. So far AD is parallel, and in math that's the parallel notation to BC. So now I want to check if AB is parallel to DC. Okay, so we're going to count out for the slope for AB what the slope is. So we have 1, 2, 3, 4, 5, 6, and it's negative since I went down. So negative 6, and we've got to find our run or our horizontal distance, which is 1, 2, and it's positive since we went to the right. So negative 6 divided by 2 is negative 3. Alright, now let's find our slope for DC. Alright, we have 1, 2, 3, 4, 5, 6, and it's negative since we were counting downwards, and we're going to count our horizontal distance or our run. 1, 2. So there we go. Negative 6 divided by 2 is negative 3. So right now I can tell that AB is parallel to DC because they have the same slopes. So that means that this quadrilateral is a parallelogram. So let's look at this. The slope of BC is 3. No, the quadrilateral is a parallelogram because both pairs of opposite sides have the same slopes. The slope of AB is negative 1/3. No. And the quadrilateral is not a parallelogram. We already answered B about being a parallelogram. So the slope of AD is 3. No, the quadrilateral is a parallelogram because all adjacent sides are congruent. We didn't find that. B03, C65, and D92. Prove that the quadrilateral ABCD is a trapezoid. Okay, so I'm thinking back to the proofs. We have to prove that at least one pair of opposite sides is parallel. And so I'm just thinking about that before I even read this proof. So let's read the paragraph proof. Quadrilateral ABCD has vertices at A, -3, -2, B, 0,3, C, 6,5, and D, 9,2. By the slope formula, the slope of AB is blank. Okay, let's find the slope of AB. So, AB slope is equal to rise is 1, 2, 3, 4, 5, and it's positive because we went up. Overrun our horizontal distance. 1, 2, 3. So the slope is 5/3. So I'm going to go down here and look for 5/3 for blank 1. So blank 1, there's 3/5. That's not it. So blank 1, 5/3. There we go. Okay, the slope of BC is blank. So let's find our slope for BC. Okay, so from B to C, our rise is 1, 2, and it's positive since we went up. And our run or horizontal distance is 1, 2, 3, 4, 5, 6. 2, 6, which does reduce down to 1/3. So let's look for blank 2 as 1/3 or 2/6. There is 1/3. Alright. And the slope of AD is 1/3, and the slope of CD is -1. Okay. It follows then that the slope of BC is to, not equal to, that we need to rearrange what our blank 4 and our blank 3 is. Okay, so since I want to change the option for blank 3 and 4 to equal to and not equal to, so that blank 5 and 6 can be parallel and not parallel, I'm going to click on the blank 3, blank 4, it sends those back. Alright, so blank 3 should say, it follows that since the slope of BC is blank the slope of AD, BC is equal to, so that's what blank 3 is going to be equal to. Blank 4 is going to be not equal to, since 5/3 and 1/3 are not the same. So not equal to is blank 4. And then we come back up here and it says, by the slope criterion for parallel lines, BC is blank to AD. So that would mean that it is parallel to it. And AB is blank to CD. Therefore, by definition, so it's not parallel. There we go. That's the order that we would like. So when you want to undo one of these click and drag ones, just click on it once. So click on the blank that you're wanting to unlink and it will unlink it. And so we're going to move on to question 7. Alright, the equation for the line L can be written in point slope form as y minus 7 equals 2 times the quantity x plus 1. If line K is parallel to line L, which equation could represent line K? Alright, so parallel lines have the same slope. So in the point slope form, where is my slope located? And it's located right in front of the parentheses that contain the x. So our slope is 2, so we want it to be parallel. So I'm looking for a slope of 2, and the only one that I see, y equals 2x. 2 is the slope right there. That's the only one that has the same slope. So that is our solution. And question 9 will be our last one. What is the equation of the line in slope-intercept form that passes through the point 5, -1 and is parallel to the line y equals 2x minus 7? Okay, so we want an equation in slope-intercept form. So we have y equals mx plus b. They're giving us a point 5, -1, and is parallel to the line that was given. And from that line, y equals 2x minus 7, I can identify the slope. And the slope is 2. It is the m, and 2 is where the m is in this. So our slope is 2. So I need to find my value for b. I've got to find my y-intercept. We have the slope, which is 2, but I need the y-intercept to make the equation. So in order to find that from a point and the slope, we're going to do the 5 is in the x spot for a specific x and a specific y. So I'm going to replace y with -1. So when you're finding b, this is the steps you go through. And then m is 2, so I'm going to write 2 times x, and where the x is, I'm going to write 5 because that was the coordinate that we had, plus b. So we have negative 1 is equal to 2 times 5 is 10 plus b. Alright, to solve for b, I want to be able to move that 10 to the other side. So the 10 is being added, and how I know that is because it's a positive 10. There's not a negative sign in front of it. So since it's positive 10, I'm going to subtract 10. I'm going to subtract 10 from both sides. So negative 1 minus 10 is negative 11 equals 10 minus 10 is 0 plus b. So then we have negative 11 is equal to 0 plus b is b. So b is equal to negative 11. So now if I want to come up with the generic equation, we are going to leave y and x in for the generic equation, and we're going to plug in our m and b. So m is 2, and we're going to leave the x for a generic equation, and our b plus negative 11. Okay, now plus negative 11 is rewritten as just minus 11. So we're looking for an equation of y equals 2x minus 11. Y equals 2x minus 11. There we go. Alright, so there are your 5 problems. Please email me if you have any questions on the other ones, and I'd be happy to help.